What's up? Welcome to Backend Stuff. I'm Jacob Blitzo, here to help you build tech for the future. Think about scalability, reliability, and cost. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. Today, we are using Phoenix to generate a controller, view, and context for a JSON resource. Before we do that, I want to jump over to UML diagram that I put together. It is so essential to think your schemas through before generating them. I'm using Figma for this, but there are many options. Just Google free options for drawing UML diagrams. You can even sketch this on a piece of paper if you want. Just make sure you put some thought into it. I like to separate account data from user data. Many examples out there will always combine them as a single table, which is terrible practice. Okay, so you can see this is super simple. I just have two tables designed here. I have a user table on the left and an account table on the right. All we have under the account right now is email, which is a string, and the hashed password, which is a string. Inserted at and updated at are automatically added, and we'll point that out in our schema once we generate them. And then we're going to have a reference to a user object here. Okay. And then our user object is everything else. It will reference our account, and then it will hold like username, gender, bio, and things like that. So things that aren't needed for the account to actually operate. And I like to set up the user object where everything can be null. We don't actually need their full name or gender or any of those things, but we do need an account ID if there's a user object created. We'll always require that reference to be there. So this is super simple. These are our first two schemas we're creating. Normally when I make a giant project, I will sit for a few days and lay everything out with their relationships and things like that. So like as we build this app out, we're going to be building up this UML diagram to show you how all of our tables are working and the relationships between tables. We will be creating an account and user schema and manually persist an object to our database. Let's go ahead and open up our Real Deal API. Drag that over. And if you didn't follow along in the using Phoenix framework to create an Elixir REST API project, you can clone the project from GitHub. That link is in the description below, or go ahead and click that link. I don't know where it shows up, but I'll make a link to the video prior to this one that gets this project all set up. So this project is a little empty, but it's where we left off. So let's make sure our Postgres Docker container is running. So if we open up the Docker dashboard, and you want to make sure that this container is running. If it's not, press the play button here. If you don't have any database containers here, I'll make a link for that episode to make sure you get a Postgres and Docker up and running. And then with that running, let's go ahead and open up our terminal, and we need to cd into our project. And my project is located in Documents, Develop, BS, and then it's the Real Deal API. We're going to use Phoenix to generate our context module, a schema, a view, a controller, a migration file for Postgres, test files for both the context module and the controller file. Let's go ahead and do mix space phx dot gen dot. So this specific command generates our controller, view, and context for JSON resources. And we don't need HTML or any of those things because we're making an API. Now all we need to do is we want to create our account stuff, right? So we're going to type in capital ACCOUNTS, accounts, and this is the name of our accounts module. So this is where all the code that interacts directly with our database will be held. And then we're doing a space, and we're going to type in account, singular this time. And account is our actual schema file being created. And then we're going to hit space, and we're going to do a lowercase a, accounts, plural again. And this is the name of our table that is going to get generated. So this will be a reference to our database table accounts, and they're always pluralized. So if you have an account object It's your accounts table. Once that's done, we just hit space and we're just creating, if you remember from our UML, we're just going to be creating an email and hashed password, which are both strings. The user reference, we don't have to worry about. We'll manually add that in our Elixir data. But as far as like data migration and Postgres, we don't have to reference backwards because our user table is going to be referencing our account. And we'll get more into that as we go through this episode. And let's go back to our terminal. Now, all we have to do is we want an email variable, colon, so no space, and then the type, which is a string. And then space after string, and we want hashed underscore password, colon, also a string. And that is all we have to do. So now hit enter, and there it created our context module, a schema, a view, a controller, our migration file for Postgres, and test files. So let's go ahead and go into our project and actually look at these. So if you expand the lib directory and the real deal API directory, you'll see a directory called accounts, and inside that is account.ex. This is our schema, all right, and we'll come back to that. And then in the real deal API, you'll see an accounts.ex underneath. This is our context module. This is where all the interaction between this object and the database will occur. All right, so that's there. And then if we come down into this real deal API web and expand controllers, you'll see that an account controller got created. And if we go into this one, this is where all of our endpoints, where we'll write functions that our endpoints can hit. So we can like have a sign in, account creation, we can have all that stuff. And we can have get account by email. And I am going to, under that create one, see this put response header? We're just gonna delete that line. We don't need it. And then save that. And then let's go ahead and fall down into the views directory. And you'll see that an account view is created. And if we go in there, you'll see that we're just returning JSON objects. So our account ID, our email, and our hashed password. And we'll be editing and formatting this stuff as we go through these next couple lessons. But for now, that is what that is. And then if you go into this priv, this private directory, you'll see repo and migrations. And if we go ahead and open this top one right here, it's time stamped, and then it's called create accounts. This is our migration file that actually creates the table on our Postgres database. Pretty cool, right? There are some things we're going to be editing, but for now, that is, oh, and then our test directory down here created a accounts test for our context file. And then it also created a test file for our controller. And we'll be diving into all this stuff too, because we'll be writing tests for everything that we create. So you now understand what the phoenix.gen.json creates. Now let's go ahead and create our user table that references our account table as well. So if we go in here, we're going to do a mix phoenix.gen.json. And now we're going to do users for our context module name, and then user for our schema name, and then underscore users for our database table name. And then space, we're going to do account underscore ID, colon, and then you're going to type in references, colon, and then accounts. So we want to call our table name, which is lowercase account, and then pluralized, so accounts. And then that's going to reference our account. And then we want to create a full name underscore, so full underscore name, colon, and this is a type string. And then we're going to do gender, colon, and this is type string as well. And then we're going to do biography, colon, and now this is going to be type text. And that is because a string is limited to 255 characters. And a bio we want to be able to support something larger than 255 characters, and text allows us to go as high as we want. So there we go. We're going to hit enter and create our user object. And now we can go through and check out the data migration, or the migration file for creating users. And you'll also see that a user controller was created, a user context file was created, and a user schema was created. Now, before we can run our Ecto migrate to create these tables in our database, we need to make some minor adjustments, okay? So let's go into our migration for accounts. So down in the priv directory, repo migrations, open this top one, and it's called create accounts. Okay, so the timestamp create accounts. We need to create a unique or a unique index. So underneath the end, right underneath the create the table, right where my cursor is, right here is where we want to type create space unique underscore index. And then we're going to do an opening parentheses, colon, accounts, comma, and then opening square bracket, colon, email, and then closing square bracket and closing parentheses. Now let's explain what this is. So creating an index basically creates one of the values in our table. So in this case, it's email. It allows us to search by that variable. So we can search our database for email if we create it as an index, okay? And creating a unique index won't allow duplicate values, so only an email can be used once. And we don't want multiple accounts created with the same email. So that is what the unique index is, okay? All right, so now with that done, you can save that, and let's go into our user migration file, which is just right underneath the account one. And we want to change a few things here. Where we have our account ID and it references our accounts, on delete, we want to change the colon nothing to a colon delete all. And what that does is if an account gets deleted, our user object associated will be deleted as well, because we can't have one without the other. So that is what that will do. And now you'll see that we already have an index created for finding users by account ID, which is pretty cool. And if there's anything else that you want to be able to query this object from, you would add it in this list. So like after account, if we did a comma, colon, we could do full underscore name. So now we can also search for users by their name, which would probably be pretty helpful. So we'll do that. Let's save that. And now let's expand our accounts directory and go into our account schema up here. And you'll see that we have our schema, and then you'll see a change set. And the change set function is called to create our object before persisting to the database. And this allows us to do all sorts of validation checks here. For now, all we're going to do is we're going to check for a unique constraint for our email value. And then we'll do a simple just regex check for the @ symbol and not allowing spaces in this value. And then when we add password authentication in the next video, we'll be doing a lot more to our account schema. But for now, let's just add some format validation. So we're going to just write down here in our change set. First of all, any value that you need to create this object needs to be in this cast option, in this cast function, okay? So we need an email and we need our hashed password. And then you can require items. Obviously, we can't create an account without an email or without a hashed password. So both those objects need to be in our validated required. So if we want to validate our email to just make sure that there's an @ symbol and that there are no spaces, we can just do a pipe operator here, and then we can call validate format. And then we're going to be passing in email. Okay, so we're going to type ~r, and this is how you begin all regex checks in Elixir. And then we're just going to do a / caret, opening square bracket, caret, back square bracket, S, and then closing square bracket. And then we're going to do a plus, an @ symbol. And then we want to just do the same thing we did on the front side of that. We're going to do opening square bracket, caret, \S, square bracket, plus $, square bracket. And there's a lot of good resources out there to understand regex. So if you don't understand or you want to understand what I typed, get out there and look. Maybe I'll make a basic video about it. But for now, all you have to understand is this is not allowing spaces, and it's checking for or the @ symbol. So our email has to have an @ symbol. And then we'll just do a comma here. And then if it doesn't match this, we'll return a message and we'll say must have the @ and no spaces. Okay. And then closing quotation and then close off that parentheses. And this is just a very simple email validation. And then we can also do things like this. We can do validate length, and we'll pass in our email argument again. And then we can say max 160 characters. And now we did that. And then also let's do another pipe operator. And we want to have this a unique constraint. So now we're going to have this in our change set, and it's also on our database. So before, if we didn't put this in our change set, our API code would allow it to go to the Postgres database, but then it would get rejected there. This way, before it gets there, we're going to reject it if it's not unique. And then we'll just pass in our email here and close those parentheses. So super simple. We'll be diving more into this in the authentication episode. We want to change a few things now in our user schema as well. So our user schema right now has this field account binary ID. We want to delete this because we want it to, instead of being a field, we're going to say belongs to space and then colon account, comma, and then we want to just reference our schema. So that is going to be the real deal API dot accounts dot account. That is now establishing the relationship between our user object and our account object. And now we can go back to our account schema under hashed password. We can do has1 and then colon user. And then we will just do, we'll find our user schema as well, which is the real deal API dot users dot user. And that will allow us to create the relationship when we create user objects with just passing in our account. It's really, really cool. And we'll dive more into that later, but just know that this has one. It does not need to be in the migration file, but we do need it in our schema for later down the road when we start creating user objects to automatically create that account reference, okay? So now let's go back to our user schema, and we need to add the account ID in our cast because we want to always make sure that's required. So account underscore ID needs to go in this cast list, all right? And then validate required. Let's delete full name, gender, and biography. We're going to allow all those to be null, okay? But we do need our account ID because we don't know who that user object belongs to without an account ID. So that's all we're going to require here. And now save it. And now we should be ready to run our Ecto migrations. So let's pull up our terminal here. And if we do mix space ecto.migrate and hit enter, it created our tables for us. So you see it created accounts and users. So that is really cool. I'm going to go to our account context folder here. So accounts.ex, and we have this create account file. And all we have to do is pass in a JSON with an email and our hashed password, and then it will insert it into our database for us. So let's go back to our terminal and let's spin up our Elixir shell, okay? So IEX dot or space dash capital S mix. And now if we do the real deal API dot accounts dot create account, and now opening parentheses, and now we just have to pass in a JSON object. To create a JSON object in Elixir, we just do the % and then opening curly brace, and then we do email, colon, space, and then opening quotation marks, and then an email address. So we're going to do, let's do backend at stuff.com, and then closing quotation marks, comma, and then we have space, hashed underscore, password, colon, space, and then we're going to type our hashed password here. And our hashed password would never be what the user's actual password is. So the proper practice with taking passwords is when you're on the front end and they type in their password, the front end hashes it and sends it to the endpoint in a request. Our endpoint receives that data. It's a hashed password, so you couldn't even grab the real password from our end, right? but we'll always receive the same hashing from the front end. And then we take that hash password and we hash it again and store it in our database. So as long as when we check the hashes, they'll always match, and we'll never actually know our user's password. So this is a hash password. So I'm just going to say open quotation. This is hashed, and then close those quotation marks. And then we just have to do closing curly brace, closing parentheses, and hit enter. And let's see, we got an error. Hashed password can't be blank. Oh, it's hash password. Let's go ahead and just... So there, you saw our validation works. So that's cool. So just delete the ED. It's hash password, and then hit enter. And then boom, our object is now created, which is really cool to show you. So right now there are some other tools that I use to see my database live. Data Grip by JetBrains is a program I really love. It is not free, but it is incredibly worth it. But for now, let's just go ahead and pull up our table. If we open up our dashboard to Docker and click on our running container and go to terminal, let's log into our database. And you do that by typing lowercase psql space dash capital U space backend underscore stuff. This is the username, right? And then the database that we want to connect to. So space real underscore deal underscore API underscore dev. All right. And then hit enter. And now we are in our real deal API dev database. And then to see our accounts table, all capital letters, type in select space asterisk space all caps from space, and then all lowercase, the name of the table you want to see. And that's accounts, and then do a semicolon after that and hit enter. And now you'll see our table. So we created this in the database. You see that our ID, our email, hash password, and then the inserted at and updated at values, which we didn't create, but those are automatically there. And if you look at the schema file, you'll see a timestamp function being called, and that's what is happening with that. But then you'll see that we have a binary ID that's been generated, which is really cool. You'll see our first account email here created, and our hashed password, which would be an unreadable value, right? But it would always be the same. And then our inserted at and updated at values. And there you go. So we created our first schemas, and now we know our database is working because we migrated and created our first two tables. And we created two schemas, and we lightly touched on what Phoenix actually creates. But as we dive into authentication in the next video, we'll be getting our hands real dirty in the accounts controller, the account schema. We might even have to add a migration file. So whenever you change something in a schema, you have to create a new database migration file. So everything properly gets changed, and we'll be making some authentication. So we'll be making a login endpoint and account creation, where when we create an account, it'll also create a user, and we'll be doing all of that in the next coming episodes. But today, boom, we created two schemas. We got everything set up. We figured out how to get our migration files to create tables in our database, and then we even manually inserted an object. As always, if you need help or want to check out the solutions, check out that GitHub link in the description below. And if you have more questions or just want to hang out and chat, please join my Discord server, Backend Stuff. That link is also in the description. If you want to learn how to build scalable, production-ready APIs, hit that subscribe button now. See you next time.